Hello everyone. Today's question. What is the mechanistic pathway for base hydrolysis of pentamine chlorocobalt? So the four options that are given. First of all, I am writing the question. Pentamine chlorocobalt. When it undergoes base hydrolysis, what is the mechanistic pathway? Four options given are substitution nucleophilic unimolecular, substitution nucleophilic bimolecular, substitution nucleophilic unimolecular via conjugate base, and substitution electrophilic unimolecular. So what is the option? Now if we study the mechanism, experimentally it was found to be second order rate kinetics. So if it is second order rate kinetics, if I increase the concentration of any one of the reactants, rate of the reaction has to increase. And they have done the same. They have raised the concentration of the complex, rate of the reaction has increased. They started raising the concentration of OH minus. To some extent the rate of the reaction has increased, but after a certain extent, how much ever the concentration of OH minus is increased, it is not affecting the rate of the reaction. So had it been second order rate kinetics, this should have been explained by the second order rate kinetic mechanism. If it is SN2, suppose if I propose SN2 pathway, then suppose I consider OH minus to be a nucleophile which is entering into the coordination sphere, and we can see that it is replacing chloride. If OH minus is a nucleophile, if I replace OH minus with better nucleophiles like azido or thiocyaneto, definitely the rate of the SN2 reaction has to increase, because experimentally the order is found to be second order. So mechanism generally proposed is SN2. But even if I replace that OH minus with some other better nucleophiles like azido or SCN minus, there was no increase in the rates of the reaction. So these two things were unexplained according to SN2 pathway. Therefore, there is a scientist called as Garrick. He proposed a new pathway, and that pathway is called as SN1-CB pathway. Garrick has proposed SN1-CB pathway, substitution nucleophilic unimolecular via conjugate base. According to which, what he proposed is, in the first step, there is no nucleophilic entry, but instead OH minus is not acting as a nucleophile. It is acting as a base in the fast step. And as a base, it is abstracting a proton. There are plenty of acidic protons present in amines. So one of the amines is converted into amido. And charge on the complex, we can see that it is decreased. The oxidation state of the metal remains the same. Oxidation state does not change, or charge on the complex is changing. Whatever conjugate base that is formed, that is going to react in the second step. And this conjugate base is reacting in a slow step, therefore it should be the rate determining step. In this slow step, it is losing chloride to give a 5-coordinate amido complex intermediate. It is giving 5-coordinate amido complex intermediate. And in the last step, the amido complex intermediate will react with base in water. In a fast step, it will take OH minus, and one of the hydrogens will be taken up by the amido. So this will give you NH3 taken 5, OH2 plus. This is the mechanistic pathway proposed by Garrick. And there was plenty of evidence to support this SN1CB mechanism. At least 3 to 4 good evidences can be seen, but coming to the question point of view, the mechanistic pathway for the base hydrolysis of pentamine chlorocobalt is occurring through SN1CB mechanism. Thank you.